In this video, we're going to talk about how to add a site to an already existing Voronoi diagram. So this little diagram at the bottom, you can see that there's an initial Voronoi diagram created, which has 3 sites, therefore 3 cells. In this Voronoi diagram, the 3 edges, so the 3 perpendicular bisectors, intersect at one single vertex. Now, the objective for this lesson is to go from an already existing Voronoi diagram and we add a new site. So now we have this new site D added, and we want to create a Voronoi diagram with now 4 cells. And the way that we're going to be doing that is through these 4 steps. First, we're going to find the equation of the perpendicular bisectors between our new site, in this case D, and all the other existing sites. So in this case, there would be 3 perpendicular bisectors to find: AD, BD, and BC. Once we have the equations of the perpendicular bisectors, we're going to be graphing them. And where they intersect the edges that are already here, this creates new vertices. So if I do a quick sketch of what that would look like, the perpendicular bisector between A and D would look like a line like this, right? So remembering perpendicular bisector passes through the midpoint and is perpendicular to the line between A and D. Then the perpendicular bisector between D and C would probably look something like this. And then the perpendicular bisector between B and D would probably look something like this. Right? So this is a rough sketch. We're going to be doing an example together to make sense of this. And where we see that there are intersections with these new perpendicular bisectors and the existing edges, in this case we have 2 of these points, these would be considered our new vertices. And once we have these new vertices, then we can go ahead and do the 3rd step, which is closing this new cell, so creating this new cell. And the way that we create the new cell is that we look at the new site, D, and we want to enclose D so that it's all alone in one cell. And in order to do that, we can only use the perpendicular bisectors involving D. So that means the new perpendicular bisectors will be what is the cell for D. So we start with the closest perpendicular bisector to D, which is AB. And then as soon as we hit a vertex, we stop. And then we ask ourselves, okay, which of these options for the perpendicular bisectors are the closest one to the vertex D? And that's going to be the one that is connecting the perpendicular bisector between B and D. And then I hit a vertex again. And once I hit a vertex, I stop. And I ask myself, okay, from here, should I be going up? Should I be going to the right? Or should I be going down? Which one is the closest to this site D? And we would be going down. So this means that these 3 perpendicular bisectors create the cell for D. And then the 4th step is for the remainder of this Voronoi diagram, we are going to keep the original edges. So if I choose a different color to keep the original edges, that means that coming out of this vertex, I would be keeping this edge. And coming out of this vertex, I would be keeping this edge. And now that would be the completed Voronoi diagram. Let's do an example to try and make sense of all of these steps together. So this is going to be our example. Redraw this Voronoi diagram with the added site E. So the orange lines that you see here are the initial lines for a Voronoi diagram involving points A, B, C, and D, right? So A and D are creating a vertical line, so it's normal that its perpendicular bisector is a horizontal line, and then A and B are a horizontal line if we connect them together, so therefore their perpendicular bisector is in fact a vertical line. So this is a Voronoi diagram right now with 4 distinct sites, and we are adding this site E in the middle. So the first step, and this is the most tedious step, is we need to figure out what is the equation of the perpendicular bisector for all of the perpendicular bisectors involving E. So I'm going to go ahead and do one example. We're going to do A and E together, and then I'm going to ask you to pause this video and do the remainder 3 by yourself. The first step in order to find the perpendicular bisector between A and C is to calculate the midpoint between A and C. So the midpoint, using the midpoint formula, we are adding the x variables together. So x of E is -2, x of A is -4, and then we divide by 2. That's going to be the x coordinate of the midpoint, and then we do the same thing for the y coordinate, and that's going to be the y coordinate of the midpoint. So when we simplify this, we're going to get -3 and 3. So the midpoint -3 and 3 is somewhere here. Let me put it on our map. Second, let's find the slope between A and E. So the slope between A and E, we're using the equation in the formula booklet where we subtract our y coordinates and then we subtract our x coordinates together. So we get -4 on the top, and then -2 plus 4, we get +2. So the slope between A and E is -2. So that means connecting A and E, we have a -2 slope. So if we want the slope of the perpendicular bisector, well, we're going to have to do the negative reciprocal. So the slope is going to be +1/2. Right? So this indicates that we're going to be rising 1 and we're going to be running 2. Now, if I would have to find the full equation of the perpendicular bisector, then my fourth step would be to replace the slope and a point, the midpoint, into this equation in order to find my y-intercept. However, this question is simply asking us to draw the Voronoi diagram. So I'm going to omit this step for now because I can use the slope and the midpoint in order to graph my line. So starting from my midpoint, I can use the slope and I can rise 1 and run 2, and that's going to give me another point on my line. And then connecting this together with a straight line, for you it's going to be using a ruler, we get that this would be the perpendicular bisector between A and E. Now what I'm going to ask you to do is pause the video, and I would like you to do these 3 steps for the perpendicular bisector between E and B, and then again between E and C, and then again between E and D. So now that you have all of your perpendicular bisectors drawn on your graph, you're going to use a pen to label these new vertices. So the new vertices happen when the new perpendicular bisectors cross the existing edges. So we have one here that I put in black. I have another one here, another one here, and another one here. So these are the new vertices because they're intersecting with the already existing edges of the Voronoi diagram. And now we are going to create the last step, create the cell for E. Now, in order to create this cell for E, we have to use the new perpendicular bisectors. So I'm going to start by using the perpendicular bisector that I feel seems to be the closest to E, and it's this pink one. And I remember that when I touch a vertex, I stop. So this line here is going to be part of the cell for E. When I touch a vertex, I stop. From here, I have to ask myself, do I want to continue towards the right, towards up, or towards the left? And again, I'm trying to enclose E all by itself. So I'm going to choose the edge that is the closest to E. In this case, that would be the purple line. So this would be the edge that finishes cell E. Once I'm at this vertex, then I ask myself the same question. Which of these perpendicular bisectors will close the cell for E? In order to close the cell for E, this perpendicular bisector is the closest. And then the last step is, again, ask yourself the same question, and we are closing the site for E. Once the site for E is all completed, right, we have it enclosed, then the last step to finish the Voronoi diagram is we are going to use the old edges in order to finish the perpendicular bisectors. So in order to finish the perpendicular bisectors, you choose all of the old edges, and this would be our completed Voronoi diagram. Only the black edges would be in this new Voronoi diagram.